Hello and welcome to Aditya classes where we have been talking about game theory these days. Today we'll take up method of subgames in this series. So method of subgames. Method of subgames is used when you get an unstable game. When you come across an unstable game and you are not able to find out a saddle point. Now when there is no saddle point, if the game were of size 2 by 2, then I could have solved it using algebraic method or oddment method. But if the game is not of size 2 by 2, suppose it is of size 2 by n or m by 2. What if the game is of size 2 by n or m by 2? That is, it has 2 rows and n number of columns, more than 2 columns. Or it could either ways be m number of rows and only 2 columns. How do we go about these kind of games? 2 by n and m by 2 games can be solved using graphical method also. Which we have seen in other videos. Here we will be trying to solve 2 by n and m by 2 game using method of subgames. So let us put up a question over here and then we'll talk about method of subgames. So the question goes like this: 1, 0, minus 1 and 0. Then we have minus 3, minus 2, 1 and 2. Minus 3, minus 2, 1 and 2. Suppose you come across a game of size 2 by 4. Now we assume that you have done the reduction of this game using dominance, pure dominance, average dominance, mixed dominance. You have reduced the game and you cannot reduce it any further. Now, how does this game get solved using method of subgames? Let us say we have A1 and A2. Here we have B1, B2 and B3 and B4. As far as A1 and A2 are concerned, we have only 2 strategies. But for B, there are various combinations from which I can pick up my strategy. Now, remember one thing. If A had multiple choices, then A would have selected the maximum game value solution. But because B is having multiple choices, B will select. As far as A is concerned, A has only 2 choices. So we need not reduce A any further, because we have probably might have seen in dominance that it cannot be reduced any further. But as far as B is concerned, we need to reduce it further, bring it down to 2 by 2. Then only can I decide which combination of B1, which combination of 2 B's is best. Is it B1, B2, B1, B3, B1, B4, whatever is the scenario. Fine. So what we'll do is method of subgames. Graphical I'll remove because graphical we will see in other videos. Right now we are learning how to solve games of size 2 by n or m by 2 using method of subgames. Now what method of subgames does is, subgame 1. It creates many subgames out of your game. The various subgames possible would be A1, A2 with B1 and B2. Now if I see, it becomes 1, 0, minus 3 and minus 2. So this is our first subgame. Now let us check if it is a stable game, and if it is a stable, we'll get our value of game straightforward. Otherwise, we'll solve it using oddment method. So A plays maximum from minimums. Minimum, minimum and maximum. Maximum, maximum and minimum. So as far as the subgame 1 is concerned, it has a saddle point. It is a stable game. If we talk of subgame 1, then it has a saddle point, and the saddle point is at A1, B2. So the value of game would be 0, and strategies would be, for A it would be 1, 0, and B it would be 0, 1. So this is our first subgame. What I am doing is I am making out subgames from this complete game. Next subgame could be something like this, maybe. We have subgame 2. Subgame 2. As far as rows are concerned, we only have A1 and A2. But for columns, I'll take B1 and B3. That will become another subgame. B1 and B3. B1 and B3. So 1 and minus 1. 1 and minus 1. Minus 3 and 1. Minus 3 and 1. We have 1 minus 3, that is B1. Then we have B3. Now let us check if it is a stable game. How do we check if it is a stable game? We get minimum, minimum and maximum. Maximum, maximum and minimum could be either. So 1 and minus 1. Definitely this is not a stable game. So if it is not a stable game, then I need to solve it using oddment method. Okay, so we'll leave it over here. We'll rewrite the game and solve it using oddments. It is not a stable game. A1 and A2 we have. Then we have B1 and B3. Values are 1, minus 3, minus 1 and 1. Difference of 1 and minus 1 would be 2. 1 and minus 3 would be 4. It will be 4 and this will be 2. So what do we have? What are the odds? Odds are 4 by 6, 2 by 6, 4 by 6 and 2 by 6. I am assuming that you have seen previous videos where we have talked about oddment method. So value of game would be minus 4 by 6 multiplied by 4 by 6 multiplied by minus 1. Then we have a 2 by 6 multiplied by 1, making it minus 4 by 6 plus 2 by 6, making it minus 2 by 6. And strategies would be, for A it will be minus 4 by 6, 4 by 6 and 2 by 6. And for B, it is going to be 2 by 6 and 4 by 6. So now, if I think from B's perspective, which game value is better? 0 or minus 2 by 6? Definitely from B's perspective, this combination is better. Why am I taking B's perspective? Because it is B who has to select between B1 and B3, between B1 and B2, between B1 and B4, as we will see now. So it is B who has multiple choices. B has to make a choice. So at least from these two subgames, the better choice looks like minus 2 by 6 as compared to 0, because for B a negative value is actually a profit. Now another subgame could be, we have checked B1, B2, B1, B3, another subgame could have been B1, B4. Subgame 3, B1 and B4. A1 and A2, B1 and B4. We have a 1 minus 3 for B1 and for B4 it will be 0 and 2. So you can check if it has a saddle point. If it doesn't have a saddle point, we can go ahead and solve it. So difference of 1, 0 would be 1, 2 and minus 3 would be 5. Difference of 1 and minus 3 would be a 4 and a 2. So odds would be 5 by 6, 1 by 6, 4 by 6 and 2 by 6. Value of this game would be 5 by 6 multiplied by 0 plus 1 by 6 multiplied by 2. We are taking it from here. Is equal to, this becomes 0, so this becomes 2 by 6. With strategies being, for A, it will be 5 by 6 and 1 by 6. And for B, it will be 2 by 6 and 4 by 6. So now if I take a pause and try to reconcile which game is best, at least up till this point. A game value of 0, a game value of minus 2 by 6 or a game value of 2 by 6. So from B's perspective, I can say that this looks like being best combination for B, at least up till this point. Any other subgames possible? I have taken a subgame with B1, B2, B1, B3, B1, B4. Yes, two more subgames are possible, B2, B3 and B2, B4. So let us have a subgame 4 with B2 and B4. B2, B4, A1 and A2. For B2 we get 0 and -2, we get 0 and B2 and B3 should have been a subgame. First we should check B2 and B3. We have checked B1 against B2, this was B3. We have checked B1 against B2, against B3, against B4. Now let me check B2 against B3 and B4. So this will be B3 and B2 against B3. -1 and 1. -1 and 1. Now you can check this game for a settle point. If you get a settle point, fine. Otherwise what we can do is, we can proceed with game of oddments. Solution through oddments. Difference of 0 and -1 would be a 1. This would be 3. This difference would be 2 and 2. Giving me 4, 4, 4 and 4. So value of game becomes 3 by 4 multiplied by 0, 3 by 4 multiplied by 0. We can take any combination. I am purposefully taking this combination because it reduces one value to 0. This combination becomes 0. So this is 0. All you are left with is -2 by 4. With strategies being, for A the strategy would be 3 by 4 and 1 by 4. 3 by 4 and 1 by 4. And for B it will be 2 by 4 and 2 by 4. 2 by 4 and 2 by 4. So these are strategies for B. Now if I take a pause at this point, which game looks like being best? 0 and 2 by 6. Definitely minus games are, negative games are games with negative game value are better for B. So these two are no good, and among these two this is -50%, -0.5, and this is -0.33. So definitely this game looks like being still better as compared to subgame 2. Now do we have any more combinations? Yes, we have a couple of more combinations left. So let us go ahead and check those combinations. We have checked B2 against B3. Subgame 5 would be B2 against B3 is done. B2 against B4 would be subgame 5. B2, B4. Here we will be having same A1 and A2 with values B2, B4, 0 and -2, and B4 is 0 and 2. Now you can check if this game has a settle point. If it has a settle point, fine, but you'll see that it doesn't have a settle point. So we can go ahead and solve it using oddment method. So difference of 0 and 0 would be 0, difference of 2 and 2 would be a 4. Here difference would be 2, here difference would again be 2. So these become the strategies. Value of game would be, you can take either of these, 2 by 4 multiplied by 0 plus 2 by 4 again multiplied by 0, giving me a value of 0, with strategies for A being 4 by 4 and 0 by 4, while strategy for B being 2 by 4 and 2 by 4. So again, if we take a recap at this point, for subgame 5 with value 0. So we have seen that we have a couple of games which are better than 0 or positive, because for B smaller values are more enticing. B favors negative values because it is a loss matrix for it is a loss game for B. So this is 0, this is 0, these are no good, this is a positive game. These two were negative games, of which this was 0.33 and this was 0.5. So definitely up till now this game is best. Now we have one more game left which we can check at this point, which will be subgame 6. Subgame 6 would be, we have checked B1, B2, B1, B3 and B1, B4. Then we checked B2, B3 and B2, B4. Now last subgame is B3, B4. So let us go ahead and check B3 also against B4. Maybe we might get a more favorable combination for B. B3, B4 is -1 and 1. Then there is a 0 and 2. So you can check for saddle point. If you get saddle point, fine. If you do not get a saddle point, then we can just go ahead and solve it. Let us check for saddle point. Minimum, minimum and maximum from this. Maximum. For A it is maximum. Minimum, minimum in each row and then maximum from it. For B it is minimax. So minimum from maximums. Maximum, maximum and minimum from them. So we have a saddle point in this. So value of game is 1. Strategy for A would be 0 and 1, while strategy of B would be 1 and 0. Now we have all our subgames. This is the method of subgames. Yes, it is a lengthy method, and definitely the graphical method is an advancement over method of subgames. Because here we had to check 1, 2, 3, 4, 5, 6 subgames. In graphical, what happens is you get only one subgame, which is best subgame. In any case, this was the method of subgames. Now you have all the values. We are talking of choices for B. So which choice is best for B? You have a 0, positive, 0, positive. So zeros and positives as compared to negative returns are better for B. So definitely subgame 1, subgame 2, subgame 3, these are no good for B at least, because they lose to the negative combinations. B is also getting smaller values as compared to these values. These subgames are no good for B. 1, 2, 3, 5, 6. Okay, this was second one. Okay, this was second one. So 1, 3, 5, 6 are no good. 2 and 4 look like being good. But this is, if we compare these two, which is the smaller value? -2/6 or -2/4. If we go ahead and solve it, this will become -0.33 and this will become -0.5. So this is far more smaller as compared to this. So B will favor this game. Hence the solution of this game is subgame 4, that is B2, B3. Now we can write down complete solution of this game. Value of game would be -0.5. Value is -0.5. Strategy for A is 3/4 and 1/4. 3/4 and 1/4. And strategy for B would be, you have B2 and B3. So B1 is gone. Strategy for B would be, B1 is gone. We only have B2 and B3 with a probability of 2/4 and 2/4. Then B4 is again gone. This is the solution of given game using method of subgames. Now this was a game where we had order of 2 by n, 2 rows and n number of columns. So B was having variations. B was having to choose best combination from B1, B2, B3, B4. So he made various combinations and finally he selected this subgame 4, giving me a strategy of this. Now let us try a game which is of order m/2, that is multiple rows and only 2 columns. So I'll remove this and put that game and then we'll go ahead and solve it. So here we have 2 more games which have been reduced down to m/2. Now the previous one was 2 by n, 2 rows and n columns. This time we have 2 games where we'll practice m/2, that is multiple rows, 3 rows and only 2 columns. So let us go ahead and solve the first game. First we'll practice with this question. Subgames in this would be A1 and A2. So can I write subgame 1 having A1 and A2? with B1 and B2, of course, because there are only two options. This time it is A who has to decide what will be his subgame strategies. A1, A2, A1, A3, A2, A3. So first we are going with A1, A2. What are the values? Values would be 6, 0, minus 1 and 4. Now you can check this game for saddle point. If it has a saddle point, fine. If it doesn't have a saddle point, we can go ahead and solve it using augment method. So what will be, you can check the saddle point, minimum, minimum and maximum, maximum, maximum and minimum. So definitely this game does not have a saddle point. So what I can do is I can go ahead and solve it using augment methods. Augment method, which says difference of 6 and 1 would be 7, difference of 4 and 0 would be 4, difference would be 6 and 5. So we get 4 by 11, 7 by 11, 6 by 11 and 5 by 11. Value of game would be, let us pick this combination. So this element becomes 0. 5 by 11 multiplied by 0 plus 6 by 11 multiplied by 4, making it 24 by 11. Now the idea is you can pick any combination. You could have picked 5 by 11 and 6 by 11 along with 6 and minus 1, or you could have picked 4 by 11 and 7 by 11 with this combination, 4 by 11 and 7 by 11 with this combination. You can pick any combination. I have taken this combination. So value of game comes down to 24 by 11. Now strategy for A would be 4 by 11 and 7 by 11. 4 by 11 and 7 by 11. Strategy for B would be 5 by 11 and 6 by 11. So this is my subgame 1, A1, A2. Now let me pick subgame 2, that is A1, A3. Subgame 2, which will be B1, B2 against A1 and A3. A1, A2 is done here. Now I am taking A1, A3. So I get 6 and 4 minus 1 and 3. 6 and 4 minus 1 and 3. So you can check if it is a stable game. Minimum, minimum, maximum, 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 minimum. So if you see, this game is a stable game. This subgame is a stable game. So I get minimum, minimum, maximum, 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 minimum. Both are pointing to this point. So value of game becomes 3, with strategy for A being 0 and 1, and strategy for B is again 0 and 1. So if I take a pause at this point, which game looks like being better one? You have subgame 1, you have subgame 2. This game has a value of 24 by 11, which is 2 point something, while this game has a value of 3. So at least from subgame 1 and 2, I can say that subgame 2 is better. That is, in a combination of A1, A2 and A1, A3, A1, A3 is looking better for A. This time I am taking larger value. Why am I taking larger value? Because this time A has various combinations from which he can select. So why will he go with A1, A2? He will definitely go with A1 and A3. B has no choice. B is stuck with B1 and B2. Last time A had no choice. A was stuck with A1, A2, while B had multiple choices. So at least up till this point, subgame 2 looks good. A1 against A2, A1 against A3. Now there is another subgame which is A2 and A3. So let us go ahead and try and solve this one. We get our subgame 3. Subgame 3 would be A2 and A3. For B it is again B1 and B2. For A you are getting A2 and A3. So it will be 0, 4, 4, 3. 0, 4, 4 and 3. You can check if it has a saddle point. If it doesn't have a saddle point, we'll go ahead and solve it the normal way. So minimum, minimum, maximum, 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 minimum. So it doesn't have a saddle point. So what I can do is I can remove this and I'll try to solve this using augment method. Augment method would suggest me that difference of 4 and 4 is 4 and 0 is 4, 4 and 3 is 1. Difference of 4 and 0 is 4, difference of 4 and 3 is 1. So my my strategies become 1 by 5, 4 by 5 and so on. Value of game would be let us pick this combination. 1 by 5 multiplied by 0 plus 4 by 5 multiplied by 4. So this becomes 0, giving me 16 by 5. So 16 by 5 is 3.2. So it is still better than this. This was 2 point something, this was 3, and this is 3 point something. So this is definitely better as compared to even subgame 2. What will be the strategies? Strategies would be for A, I suggest a strategy of 1 by 5 and 4 by 5. And for B, the strategy suggested is again 1 by 5 and 4 by 5. Now you can finally take a call which subgame is best. I have checked all subgames. Only 3 subgames were possible: A1 against A2, A1 against A3. Subgame 1, subgame 2, and this one is subgame 3. So which is the best value? This is the best value. So I would go ahead and say that solution for game 1 value is equal to 16 by 5. Strategy for A would be A2 and A3 are here. A2 and A3 are here. A1 has lost it. So A1 is 0. A2 and A3 are 1 by 5 and 4 by 5. And B has a strategy of 1 by 5 and 4 by 5. It had only 2 combinations. So this is our solution to first game of size m by 2. Now this is a game which you can practice for yourselves. I leave it over here. This is method of subgames for games of size 2 by n and m by 2. Next time when we meet, we'll pick up some more methods of solving games in game theory. Until we meet next time, do take care. Thanks for watching. Bye-bye.